In this lesson, we'll be talking about the rectangular coordinate system and graphs.
This should be familiar to most of you in the idea of being able to plot ordered pairs. An ordered pair, in this case we're calling it AB, but it's just like the terms x and y. We've got two real numbers, and the first coordinate and the second coordinate, we often will use those as the x and y coordinates. What we're going to be doing is looking at equations where the ordered pairs, the x's and the y's, when we plug them in, they create true equations. Here's your Cartesian coordinate system. We've got the x-axis and the y-axis, and these together make up what we call this coordinate system. We've got various points, and the points that we plot, we always put the x-coordinate first and then the y-coordinate. So the x-coordinate to the right is positive and to the left is negative. The y-coordinate above is positive and below is negative. So the x-coordinates and the y-coordinates, the x-axis and the y-axis, are usually horizontal and vertical, respectively. And then finally we've got the place where they intersect. That's 0 on the x-axis and 0 on the y-axis, and we call that point the origin. Finally, whenever we look at these four regions that are created, we call them the quadrants, and we go counterclockwise. Quadrant 1, 2, 3, and 4. So you'll want to familiarize yourselves with which quadrant is which. Let's do an example. To plot a point on the Cartesian plane, what we need to do is first calculate the x-coordinate, then move to the y-coordinate that has that same x-coordinate. Let's go through the examples. -2, -3. Well, we go left, -2 for my x's, and then from there I go down 3 for my y's. That's the first point, -2, -3. So again, -2 is the x-coordinate, we go left 2, and then -3 is the y-coordinate, we go down 3. And that one is, if we label our quadrants 1, 2, 3, and 4, we can clearly see that the point -2, -3 is in quadrant 3. Next example, 1, -4. So we're going to go to the right 1 for my x-coordinate, and then -4 for the y-coordinate means I'll go down 1, 2, 3, and 4. And so I get 1, -4 as my point here. Now that one, if you look, is in quadrant 4. Alright, 0, 5. Pay careful attention to which variable is 0. In this case, 0, 5 means the x-coordinate is 0. So on the x-axis, I'm going to go to 0 on the x-axis. Now let's move on the y-axis, up 5. 1, 2, 3, 4, and 5. Now it's not in a particular quadrant, so we need to say that it's on the y-axis. Next one is 1, 3. So I go right 1 and up 3. 1, 3. And that is in quadrant 1. Next, -3, 1. 1, 2, 3 left, because it's negative, and 1 up for the y-coordinate. -3, 1. And we see that this one is in quadrant 2. Alright, the final one is -2, 0. So again, use caution here. Pay attention to which one's the 0. 0 is the y-coordinate. So I'm going to be on this y-axis at 0, and x is -2. So -2, 0 here. To give this a quadrant, it's not on any particular quadrant, but it is on the x-axis. Next formula in this first section is how to find the distance between two points in the plane. So the distance between these points is given by what we call the distance formula. What you do is you subtract your x-coordinates and square it, subtract your y-coordinates and square it, add those together and take the square root. So this formula, once you get used to it, is pretty quick and easy. Let's just go right into it. I'll call this x1, y1, and x2, y2. These are just the coordinates of the 2 points that you're given. So the formula is x2 minus x1. So there's 2 minus -2 squared. plus y2 minus y1 squared. I get, that's 4 squared plus 3 squared. So I get 16 plus 9 is 25, and so the distance is 5. Next question. Still using the distance formula. x1, y1, x2, y2. x2 and x1 is 4 minus negative 2 squared, plus y2 minus y1 is negative 1 minus 1 squared. So I get the square root of 6 squared plus negative 2 squared. That's 36 plus 4 is the square root of 40. Now that doesn't simplify down to a whole number, but I could write it as the square root of 4 times 10 and just get 2 times the square root of 10. So there's your distance formula. Midpoint formula. So the midpoint formula tells you to add the x-coordinates and divide by 2, and then add the y-coordinates and divide by 2. Now, what this actually is just an averaging. If you think about it, the average of the x-coordinates is exactly this, and the average of the y-coordinates is exactly this. So you can think of the distance formula not so much having to memorize the formula, but just think average of the x-coordinates, average of the y-coordinates. Midpoint. Now I should add, this is not going to be a formula that gives you a number. This gives you another point. x1, y1, x2, y2. x1 plus x2 is negative 2 plus 4 divided by 2 according to the formula. y1 plus y2 is 1 plus negative 1 divided by 2. And so I get 2 over 2 is 1. 1 plus negative 1 is 0, and 0 over 2 is 0. So there's your midpoint between these 2 points. Second example, let's not write down the x1, y1 thing. Let's just take a look at the average. So negative 2 and 2 are my x-coordinates. To average them, I'll add them together and divide by 2. And then my y-coordinates, negative 1 and 2 are what I'm averaging together. So I get negative 2 plus 2 is 0. 0 over 2 is 0. Negative 1 plus 2 is 1, and dividing by 2 I get a 1/2.